Here's a few more diploma questions about equilibrium theory, some lechat, stresses, and one that sets up ICE, but you don't have to do any solving, which is nice. So this first one, we're given our equation, some information about this equilibrium system here, which we'll continue to use throughout this video. And it's asking us which of the following would not be an observation. Now I have to admit this one stumped me a little bit because we usually in the definition don't talk about mass or number of gas molecules. But in this, if it's in equilibrium, our mass would be constant. Pressure for sure is constant. Temperature, we definitely know that's part of the definition. But what's not constant is the number of gas molecules. And that would have to do with actually looking at the fact that we only have 2 on the left and 4 on the right. I'm not sure if I'm even thinking about it the same way, but that is definitely the answer, but it's just that the system itself would have a constant mass. Within the system, though, we can change the amount of gas molecules we have depending if we're more on the left or on the right. The next question here is to do with lechat stresses. So same thing, we have that same equation, and then this one is asking which one would cause a shift towards the reactants. So we want to shift left. So our first one, if you add in H2, you would shift left. If you add in, you shift away. So because it's on the product side, we're going to get more reactants. So definitely number 1. If we add in CO2 is on the reactant side. So if you add it in, you shift away. It's going to shift towards the products. Adding a catalyst does not cause a shift, so that's not a choice. Removing CO, carbon monoxide, is on the product side. So removing tends to cause students frustration. Always go with what you know. If we add in, you shift away. So if you take it out, you shift towards. You want to replace what was taken out. So removing of that definitely would be a shift to the I'm sorry. I'm going the other way. Removing it, you're going to shift to the right, and that's actually not what it's asking for. So removing CH4, on the other hand, we would shift back to replace it. So it would have been number 5 here. And then the last one, the decreasing the volume of the container. So remembering that volume and pressure stresses only apply to gases, and then it's based on number of moles. So what I tell my students is I always remember that if I increase the volume, I move to the side with more moles. Now that might not work for you to remember, but this works for me. So you might want to come up with your own way to remember. So in the opposite end, if we're decreasing the volume, we're going to move the side to the side with less moles. So the left-hand side here has 2 moles total. The right-hand side has 4. So if we decrease the volume, we will shift to the left, move to the side with less moles. And so that would be number 6. Now, this next one is about your graphs and what's happening to establish equilibrium. So it's telling you that originally you're putting 1 mole of CH4 and 1 mole of CO2 into your container, and then equilibrium is allowed to establish. So with this, we want to see reactants being used up. And in all of them, we do see that the reactants are going in that downward kind of trend, and products are being formed. And then we want that flattening of the line. Now, the only difference between the graphs is how fast that is happening. And now this is based on the mole ratio. So because this is a 1, 1, 2, and 2 ratio, these products are going to form twice as fast than your reactants. So the only graph that does reflect that is A. Okay, so we are seeing that. I just want to make sure I'm not missing because the other ones are definitely not showing that. And then the last one here is related to the part about what's initially being placed. So if I just go back here for a moment, this 1 mole and 1 mole. So this is going to be an ICE question, and then they're asking us how could you figure out the concentrations change for CH4. So with that, if you did set up your ICE question or table, we know that we had 1 mole per liter of each of these put in, so 1 mole per liter, and then if it doesn't tell you otherwise, you could assume your products are not present initially. Now your change is based on your mole ratio, so reactants are used up, so minus x, products are being formed, so plus 2x plus 2x. So I'm getting this 2 because there's that 2 in front. Then at equilibrium, we're just adding our columns, so we'll have 1 minus x, 1 minus x, 2x, and 2x. Now, if you set up your Kc expression based on what we see from your equation, you would have the concentration of CO squared times the concentration of hydrogen squared divided by the concentration of CO2 and the concentration of CH4. So again, these 2's are coming in to be our exponents. So now if we replace what we know, and we know that at equilibrium, this is the part we want to use or take to fill in Kc. My CO is this one, so I'd have 2x squared times my hydrogen is 2x squared as well. This is divided by my carbon dioxide, 1 minus x, and then 1 minus x for the methane gas. And now all of this equals your Kc value, and your Kc value was given to you in the previous question in the text box. So now that I have this all set up, I want to see which one matches. And I had D cut out here. Luckily, that wasn't the answer. So the one that I'm taking a look at so far would be B to match completely, because we do have 2x squared, and instead of writing this out twice, writing it once and saying to the power of 2, that is the same thing. So as always, I hope you found this helpful. If you did, please subscribe, and if there's any other video I could do for you, just let me know. Thank you for watching.